Atlas, an outsider older than our Sun. There's something extraordinary drifting through our solar system right now, a visitor older than the Sun itself. Astronomers call it 3I Atlas, the third confirmed interstellar comet. It didn't form here. It came from somewhere beyond, carrying the fingerprints of a completely different star system, maybe one that died billions of years ago. Spectroscopic analysis stunned scientists. The isotopic ratios of oxygen and carbon inside its faint coma, T, match any known pattern from our solar neighborhood. That means this object predates the Sun, older than 4.6 billion years, perhaps as old as 7.5 billion years, drifting silently through interstellar space before crossing our path. Professor Brian Cox explained it best. Objects like 3I Atlas are fossils of other worlds, frozen records of how planets formed before our Sun even existed. Imagine it a fragment of ancient cosmic history gliding between Mars and Jupiter, older than Earth's oceans, older than life itself. And yet, despite being ancient, it behaves unlike any comet we've ever tracked. It doesn't flare or form the long, glowing tail we expect. It doesn't fit the thermal models that predict intense sublimation near sunlight. Instead, Atlas drifts calmly, more like an engineered probe than a chaotic snowball. Its motion breaks rules that once felt unbreakable. This isn't just another dusty traveler. It's a messenger from a time before our solar system was born. And scientists, including Cox, say that studying it may rewrite how we understand planetary formation itself. If you could sample the dust of 3I Atlas, you'd find something shocking. The comet is rich in water ice, yet almost completely lacks iron. A contradiction to everything we know about comets. Normally, comets contain a mix of frozen volatiles, silicates, and trace metals like iron and nickel, remnants of the solar nebula that built our planets. But Atlas, it's different. Spectrographic data from multiple observatories, including ESA's Solar System Mapping Network and NASA's Hubble Follow-Up, show the telltale hydrogen emission of water vapor, but no iron spectral lines. It's as if Atlas came from a star system that never formed heavy elements. That's what makes it priceless. If it truly contains pre-solar material, it offers a snapshot of chemistry before iron-rich stars seeded the galaxy. In simple terms, this comet may come from a cosmic era before our periodic table was complete. Adding to the mystery, only 8% of its surface appears active. That means most of the comet's crust is inert, locked under an ancient, possibly radiation-scorched shell. Yet, even with minimal activity, scientists detected faint water emissions, suggesting subsurface reservoirs of ice still survive after billions of years. Brian Cox called it a molecular time capsule. Every molecule on it is older than our planet's crust. Studying that chemistry might tell us what ingredients the first generation of stars left behind, and how early solar systems formed worlds like ours. So when you hear 3I Atlas has no iron, remember, that absence is its greatest gift. It's not what's in it that matters most, it's what's missing. When astronomers first detected 3I Atlas, they expected fireworks, a massive plume stretching millions of kilometers, glowing as solar radiation tore vapor from its surface. But that tail never appeared. Atlas broke one of the oldest rules in comet science. Instead of forming a long, bright streamer, it produced only a faint haze, less than 1/10 the activity seen in ordinary comets. Measurements from NASA's Solar System Dynamics Observatory estimate just 8% of the surface is active. The rest, completely silent. Why? Because Atlas may be the most dormant comet ever recorded. Its surface is ancient, bombarded by cosmic radiation for billions of years, forming a crust so thick and carbon-dense that sunlight barely penetrates. Inside, ices remain sealed under layers of rock-like material. Normally, when a comet nears a star, frozen gases sublimate, turning solid ice into gas that explodes outward. But on Atlas, those gases are trapped. The tiny plumes that do escape are weak and localized, producing no dramatic tail. Spectroscopy backs it up. Traces of water vapor are there, but no extended dust structure. Professor Brian Cox explained it simply. Atlas has traveled for longer than the Earth has existed. Every molecule on its surface has been baked and frozen thousands of times. The fact that it still releases anything at all is astonishing. So, when people look for a glowing trail across the sky and see nothing, it isn't a failure. It is proof of just how old and resilient this visitor truly is. A comet that defies the textbook, surviving longer than the star systems that made it. Atlas isn't a comet showing off, it's a relic that refuses to die. Then came the photos. Captured by NASA's Perseverance rover, 3I Atlas appeared as a perfect glowing cylinder drifting over the Martian sky. No tail, no fragmentation, just a strange, structured glow. The image went viral instantly. A user on X wrote, "A perfect glowing cylinder drifting across the Martian sky, no dust plume, no fragmentation, just structure." That photo was taken from about 38 million kilometers away by the rover's navcam. At first glance, it looked impossible, a solid beam of light hanging motionless. Harvard professor Avi Loeb offered an explanation. The cylinder's shape might come from image stacking. The navcam combined hundreds of exposures over 10 minutes, creating an elongated blur. In his words, the appearance is likely an artifact of long exposure stacking, not an object's true shape. But here's the twist. Other independent telescopes recorded the same feature: no tail. Even with higher resolution imaging, Atlas remained unusually compact with no extended trail of gas or dust. That consistency left scientists uneasy. If multiple instruments across different platforms confirm a structure without a tail, something deeper is going on. Either Atlas's outer layers are so inert that dust never escapes, or its composition is fundamentally alien to any known comet type. Brian Cox summarized it like this: when something refuses to behave like every model predicts, that's when science gets interesting. So whether it's a visual illusion or genuine structure, those Martian images changed everything. They showed the world that 3I Atlas isn't, just another frozen rock. It's the most disciplined traveler ever seen. When Professor Brian Cox first discussed 3I Atlas, he called it a frozen relic from before the sun. He wasn't exaggerating. According to Cox, Atlas may have formed in the first generation of planetary systems, long before our solar system even existed. Imagine a world orbiting a star twice as old as ours, a place where heavy metals were rare, iron was almost non-existent, and chemistry was simple: hydrogen, oxygen, carbon, and a lot of primordial ice. That's where Atlas was born. Cox explains that in the galaxy's early days, the first stars created the building blocks of planets. When those ancient stars exploded, they spread dust and gas into surrounding space. Out of those ashes, systems like ours, and Atlas's home system, took shape. But Atlas's composition tells us it may have escaped before its system matured. He compares it to a fossil, a time capsule drifting through billions of years. We're literally looking at a survivor of galactic evolution, Cox said. It's like finding a drop of water that never evaporated in a cosmic storm. Scientists believe Atlas's current orbit through our solar system is pure luck. It is passing close enough to Mars and the Sun to let us study it, but not close enough to burn away its secrets. And here, the kicker. The data suggests that Atlas' orbit didn't just drift in naturally. It was likely thrown here, ejected from its home star by a massive gravitational encounter, perhaps when two stars passed dangerously close in their early cluster phase. In Cox's words, every now and then, gravity tosses a world into exile. Atlas is one of those exiles, and it is telling us how ancient systems lived and died long before ours began. Now, let's talk about that exile. how Atlas ended up as an interstellar wanderer. Astrophysicists believe the comet was flung out of its original solar system billions of years ago. Here's how that happens. In young star clusters, newborn stars sit close together, their gravity constantly tugging at each other's planets, comets, and debris. One wrong nudge, a close flyby, or a giant planet migration, and an object, like Atlas, can be ejected at escape velocity, breaking free of its star forever. That's what scientists think happened to Atlas roughly 7.5 billion years ago. It may have formed in the outer edges of a star system, beyond its snowline, before being tossed into deep space during a chaotic gravitational shuffle. From that moment on, it became what Brian Cox calls a galactic orphan. Since then, it's traveled through multiple regions of the Milky Way, exposed to radiation, supernova remnants, and cosmic rays, all while staying mostly intact. Its tough, iron-free shell might be what kept it from disintegrating. Ironically, the very thing that makes it unusual, its lack of metal, could be what kept it alive. Even more fascinating, trajectory modeling shows Atlas didn't just wander randomly. Its speed and direction suggest it may have passed near several stellar systems before crossing into ours. A journey taking longer than the entire lifespan of our Sun. As Cox puts it, Atlas is the ultimate survivor. It's older than the planets, older than our oceans, older than the idea of Earth itself. It has been drifting through the galaxy since before the Milky Way had spiral arms like it does today. Now it's here, for a brief cosmic moment, before it slips away again, taking its 7.5 billion-year story back into the dark. Picture this: a single block of ancient ice, smaller than a city, floating in absolute darkness, traveling at over 60 kilometers per second through the galaxy for 7.5 billion years. That's 2.4 trillion orbits around the Milky Way's center. That's how long 3I Atlas has been drifting, untouched, unseen, and older than every mountain, ocean, and organism on Earth. According to trajectory simulations, Atlas likely left its original star system before our Sun even ignited. Back then, the Milky Way was still forming its spiral arms. The comet has since crossed through dense nebulae, ionized gas fields, and interstellar dust, a cosmic survivor, battered by radiation, but still mostly intact. Astronomers estimate its shell has been carbonized by cosmic rays, forming a thick black crust that preserved the pristine ices beneath. That same crust explains its minimal activity. Sunlight can't reach the interior, so it barely sublimates, just a faint whisper of water vapor, escaping through tiny cracks. And that's where the story gets poetic. After 7.5 billion years of silence, this ancient traveler suddenly enters our solar system, a region of young, energetic stars and magnetic chaos, like an old ghost wandering into a city of neon lights. Professor Brian Cox described this journey as the most profound example of cosmic endurance. He added, "We're watching matter that has never known the warmth of any star. It's older than time as we understand it." Think about that. A chunk of pre-solar ice, still carrying molecular fingerprints of the galaxy's earliest chemistry, now visible to human eyes for the first time. The odds of that happening? Roughly 1 in a trillion. And yet, here it is right now, in our night sky. Comets have rules. They form tails when heated, shed dust when fractured, and brighten as they approach the Sun. But 3I Atlas broke every single one. As it crossed Mars's orbit, it stayed dark. No brightening, no fragmentation, no extended dust trail. Instead, it behaved like a sealed capsule, a steady glow, consistent shape, and zero volatility. That's unheard of. Even the interstellar comet 2I Borisov produced a 14 million kilometer long tail. Atlas? Nothing. This has scientists rewriting the rulebook on what a comet even is. Some theorists believe Atlas is a devolatilized core, a comet that exhausted its active materials billions of years ago, leaving only a dense crust of complex carbon compounds. Others think it might be something even more unique. A fragment from a failed planet or debris from a star that never formed fully. The lack of iron and presence of water point to a time before heavy elements existed, possibly when the galaxy was still young. In other words, Atlas could be a surviving piece of the earliest generation of cosmic matter, the kind that built everything that came after. Even more curious, its rotation and brightness pattern are oddly uniform. Normally, comets spin irregularly, changing intensity as they tumble. Atlas's light curve stays stable, suggesting a balanced, almost engineered symmetry. Brian Cox commented on that too. Atlas challenges our understanding of formation physics in a way like it has been preserved in a way that shouldn't be possible over billions of years. Every telescope that points at it adds another mystery, and every answer raises 10 new questions. Atlas isn't just defying the rules of comets, it's defying the limits of what we thought nature could create. When something like 3I Atlas enters our solar system, it doesn't just draw telescopes, it divides scientists. On one side, you have Harvard astrophysicist Avi Loeb, who's been vocal about objects that break natural patterns. He pointed out the same red flags many astronomers tried to downplay: the strange cylindrical structure, the absence of a tail, and the steady light curve that never flickers like a rotating ice rock should. Loeb said the elongated shape seen in the Mars Navcam images might be an optical artifact, yes. But he also added, if future observations confirm structure and symmetry, we have to consider all possibilities, not just the comfortable ones. That comment lit a fire across the scientific community. Forums filled with speculation. Is Atlas simply a hyperdormant comet, or a relic from a system so ancient that its chemistry no longer behaves by today's rules? Some even floated the idea that Atlas might be interstellar debris from a long-lost civilization, though mainstream astronomers quickly cautioned against that leap. Professor Brian Cox, as always, took the balanced view. He dismissed the alien talk, but not the mystery. This is exactly how science advances, he said. Something unexpected appears. We test every hypothesis, and the universe either confirms our limits or expands them. Other experts, including teams from ESA, NASA, and the Galileo Project, agree that Atlas deserves continued study. They note that it's rare, possibly 1 in a billion, to capture an interstellar comet with this mix of low iron, high water, and dormant behavior. The debate remains open. Is it a natural fossil, a cosmic accident, or evidence that the early galaxy was far more complex than we thought? One thing is certain: Atlas refuses to fit inside any box we've built, and maybe that's the real message here. It's not here to confirm our models, it's here to challenge them. 3I Atlas is not just another visitor, it's a living paradox, a comet with water, but no iron, motion without a tail, and a history that predates the sun, and that means it changes everything. For planetary scientists, Atlas is a once-in-history opportunity. By studying its isotopic makeup, scientists can look back in time, to an era before the sun existed. It's like touching the raw ingredients that built our universe. Each molecule tells a story about how the first stars lived, died, and recycled their elements into the cosmos we now call home. Its 7.5 billion-year journey isn't just about distance, it's about endurance. For something so small to survive galactic radiation, gravitational chaos, and supernova shockwaves without disintegrating, that alone defies probability. It's a survivor of universal violence, the last whisper from a system long gone. Brian Cox summarized it best. Atlas is proof that the universe remembers. Even when stars die, their debris carries on, drifting across billions of years until someone somewhere looks up and finds it. But beyond poetry lies purpose. Missions are already being discussed. Intercept concepts that could one day chase down interstellar visitors like Atlas. If scientists could collect even a few grams of material, they'd hold the oldest solid matter humanity has ever touched, predating the solar system by billions of years. So, when you look up at the night sky, remember this. Somewhere out there, 3i Atlas is still gliding silently through the dark. It's older than the sun, older than Earth, older than every story we've ever told. And yet, it's real right now, cutting through the void, daring us to understand. The next time we see something like Atlas, we might be ready. Until then, the universe just reminded us how little we truly know.